Thank you, Felix. Thank you, Jane. What an honor to be at ETH in this lecture hall. I know how many distinguished scientists, really distinguished scientists, have preceded me here. It is an honor to be in front of you today. Now, Jane has asked me to talk a little bit about history, the history of the field, and if I have oh, there it is. Let's make sure this is working. Yes, there we are. In 1996, Theo Colborn, Diane Dumanoski, and I wrote Our Stolen Future. And I'm going to elaborate a little bit upon the history that preceded that, and also the consequences of our having published it now almost 30 years ago. I can't imagine 30 years ago I would be here in front of you today at ETH. It's such an honor. So Our Stolen Future is about endocrine disruption. It's about how synthetic chemicals and some natural ones can send signals that hijack our hormone systems. And I'll go into that as the lecture proceeds. The book was well received. It was published in 14 languages. There's both a German and a French edition, as well as Japanese, Korean, Chinese, etc. And that book began with 3 questions. Are we threatening our fertility, intelligence, and survival because of the consequences of hijacking the hormone system? Now, Leo Trisande is here. Leo has a wonderful saying, hormone system isn't all, it's everything about how you develop, what you become, who you are in life. It is the master conductor of our growth and development, and also our aging. So here's this question which we asked. We didn't know all the answers because the science wasn't there yet. But by that time, Theo and Diane and I had grown confident that it was worth asking those questions, because if it were true, the consequences would be, to use a technical term, ginormous. So what is the answer to that question 30 years later? Yes, we are threatening our intelligence, our fertility, and our survival. Yes. This is Theo. Tall, thin, never stopped moving until she died in December of 2014. Theo has a fantastic, fascinating history. She began professional life, as a pharmacologist with her husband. They owned several pharmacies in New Jersey, in the US. And she quit. They sold their pharmaceutical company, pharmacies, because they became convinced, especially Theo, that they were killing their patients with the drugs they were delivering. So she quit. She moved from New Jersey to run a sheep farm in Colorado. Quite a switch. But as she was there, nothing could ever stop Theo. And she became interested in the waters in Central California on the west slope of the Rocky Mountains, and began to pursue, well, what are the things that are interfering with the water quality where my sheep are growing? And she became more and more interested in that, and she wound up volunteering in a famous biological laboratory, the Rocky Mountain Biological Laboratory, which doesn't look very much in that mountain. It's at about 9,000 feet, 3,000 meters in the Rocky Mountains near a place called Crested Butte. And she was an intern there, helping some people do water quality measurements in the streams. And she was sitting there, and this place has a fantastic history because of the senior scientists who would gather there every summer and do their research and then bullshit after work with one another and talk about important things in science. And one day she was sitting in there quietly in the library, and there were two guys bullshitting. Excuse me if that's permitted here. And one of them was Paul Ehrlich, whose name I imagine most of you will recognize. And the other one was John Holdren, a physicist who much later became Obama's scientific advisor for both of his administrations. So these are two really big dudes in the field. And Theo's listening to them, and she realized, that's BS. They don't know. I know as much as they do. I'm going to go to graduate school at the age of 53 and get a PhD. She was inspired by the bullshit. And she did. She got her PhD at the age of 57 at the University of Wisconsin. And she immediately was thrust into measurements of water quality in the Great Lakes of the United States, Lake Superior, Lake Michigan, Huron, et cetera. And it led to a book called Great Lakes, Great Legacy. And one of the curious things about this, she was asked to study contamination in the Great Lakes because at that time, everyone was convinced chemicals were causing cancer everywhere. And Theo was looking at the patterns of disease and disability she saw. And yeah, there were some cancers, but that was not the big story. The big story was things like this: developmental errors in adults that she was beginning to trace to their exposure to chemicals that interfered with the control of development. This is a cormorant. This is probably the most notorious of all the EDC effects in the Great Lakes at the time, a twisted beak. But there are many other things that Theo discovered. Okay, so what does Bob Dylan have to do with this? You'll probably remember you may, I don't know how popular a Nobel laureate in literature is in Switzerland, but Bob Dylan had a phrase in his song, The Ballad of a Thin Man. Anyone remember that? The Ballad of a Thin Man? The phrase was, something is happening and you don't know what it is. And I added, do you, Dr. Colborn? Because she didn't know what was happening. But she, being a stubborn, persistent, brilliant woman, she decided to find out. She decided that something was wrong with hormones. And some people, the public at large, thinks of hormones basically as something that happens at puberty. Well, we all know that hormones are the chemical signals in the symphony of life, turning genes on and genes off trillions of times a second throughout your lifespan. And the consequences of having genes turned on or off at the wrong time can be quite severe. And so I meant to put those up earlier. Those are indicative of the fact that these signals are coursing throughout our bodies, throughout our lifespan, from right at the beginning of conception through all of fetal development, all the way to aging and death. And Theo decided, as she thought about this work, that it had to do with hormones. It must be something to do with hormones. And as you know, hormones are produced by glands throughout our body, and they go, and when things are working properly, you get into the bloodstream, and they go to responsive cells. If there's no receptor in the cell, no effect of a hormone. But typically, you have, in pretty much all cells, you have receptors, both in the cell membrane, and Angel Nadal will be talking about this shortly, but also receptors in the nucleus. And those receptors are stimulating processes that have profound influences. And what Theo began to focus on was how were the chemicals that were produced in the Great Lakes in vast quantities. Dow Chemical had a huge complex of chemical production in one of the Great Lakes, and the others were rife with chemical production also. She began asking, how are those chemicals interfering? How are they hijacking hormone signaling? Well, they hijacked in many ways. They send signals at the wrong time. They send the wrong signal at the wrong time. And they also send signals that block the correct signal. And when that happens, any of those methods, and there are other methods of endocrine disruption also, but when those disruptions, those hijackings take place, severe results can result. Theo had a brilliant idea. By then, in 1990, she became a senior fellow at a foundation where I was the director. I asked her to come aboard because we had begun to work together. And she decided to pull together the scientists, including Ana Soto. Where is Ana? There's Ana. Ana and I are the only two people here, I think, that were at the original Wingspread. But Theo decided to pull together these people whose science had something to do with hormone hijacking. They didn't know each other. Their science, the sciences they were in were quite disparate. We had reproductive endocrinologists right at the center of the phenomenon. We had psychoanalysts. We had immune system specialists. We had a wide array of disciplines represented in the 21 people who were at this conference. It took place in Racine, Wisconsin, in July of 1991. The result of this was a report published in a book published by Princeton Scientific Publishing that became known as the Wingspread Statement. Now, I played an unusual role in this because at the time, at the foundation that I was running, I was mostly interested in, this is 1990, I was interested in work in two fields, this and climate change, way back in 1990. I had gone to the foundation because I was concerned about the effects of climate change on biological diversity. So I was well versed in some of the efforts by the scientists at the Intergovernmental Panel on Climate Change, working on the policy impacts, future policy impacts of climate change. And they produced in 1990 a really brilliant synopsis of what they saw coming, which was organized as hierarchies of certainty. If you can see that, the first level was, we're scientists, but we're really certain that this is what is happening. And then there were other categories of certainty, each one with less and less certainty. We calculate with confidence that this might happen. In fact, we're pretty sure it will, but we aren't certain. It was interesting to use that formulation, and here it is, because policymakers focused on what's certain. What policymaker has ever heard scientists claim they are certain about something? Scientists always disagree. They're looking for the points of the argument that are the weakest points of the argument, and that's what they stress, we stress in our own communications. But to have a scientist, a group of scientists say, we're certain about this, that's a big deal. And there's the hierarchy that we took from the Intergovernmental Panel on Climate Change and applied it to the issue we were studying, endocrine disruption. And the certain of the following, it was quite simple. You can't be complicated if you want to get scientists to agree. We're certain a large number of man-made chemicals that have been released into the environment have the potential to disrupt the endocrine systems of animals, including humans. That was where this field began. There were signs of it early on. John McLaughlin, in particular, and Howard Byrne, early endocrinologists, had signals that it was happening, but it was this meeting that really brought it together because of Theo's genius at connecting dots that no one else, including the dots themselves, knew what was happening. Most of us scientists were really good at diving really deeply. Theo was brilliant at looking broadly, finding dots, and connecting the dots into consequential effects. One other impact there that I had at the meeting was I had just written this article about global warming, climate disruption, and biological diversity in 1990. And as I was sitting Theo asked me to chair the meeting, and I was sitting listening to all the brilliant people like Anna talking about their own science. But it was in all sorts of different directions because they were studying different dimensions of the endocrine system, estrogens, androgens, and other hormones that are involved. And I realized that it wasn't just a single pathway that was being affected, it was the entire endocrine system by different factors, but collectively, it was disruption of that system that was underway. And it was because of that background that I made the suggestion at the meeting that we unite all of these different issues under the rubric of endocrine disruption. So now we're 33 years after Wingspread and 28 years after Our Stolen Future. Where are we? Well, endocrine disruption is affecting us and wildlife in many, many different ways. The science for each of these conditions is significant. It's not all certain. Science is rarely certain, but we know that endocrine disruption is involved in those. If you glance over that, put your hand up if you or your family or your friends have someone that is experiencing one or more of these symptoms. I would suggest the people whose hands aren't up ought to be asking about the health of their family because no one is avoiding these. So probably the best known example of the consequences of endocrine disruption is work done by Shauna Swan and Haggai Levine and others, beginning with Niels Skakibach in Denmark. But they've clearly shown that endocrine disruption is driving sperm counts down. Initially, the thought was, in fact, the data were from westernized countries, but Shauna recently and Haggai have obtained data from elsewhere. This is not a good signal. This is a simple projection. Scientists don't like to make projections, but if you simply look at the slope of the curve and you ask, where's it headed? It's headed to around the middle of this century when, if they're right, most boys will not be able to reproduce the old-fashioned way. And one of the dramatic things about this curve in the most recent data is that the curve is accelerating. It's not slowing. It's not continuing steady. It's accelerating. Give you one other example of some of the effects of endocrine disruption to give an illustration of how hard it is to work in this field. This is, yes, it's the inside of a mouse. It's a male mouse. It has testes. It has a healthy kidney, and it's got a normal bladder. This is the control mouse in experiments led by Fred von Saal, who was at Wingspread and is one of the heroes of this field. He discovered that exposure to a tiny amount of bisphenol A causes epigenetic programming changes in the prostate of a fetal mouse. Epigenetic changes in the prostate of a fetal mouse whose consequences are not visible at birth, but gradually appear as the mouse ages, and mouse and people, men, as they age, the ratio of testosterone and estrogen changes. We get less testosterone per unit of estrogen. And that change in the ratio causes the urethra, causes the prostate around the urethra. The urethra is what we pee through. It causes the urethra to be constricted and ultimately to be blocked. Now, anyone my age is familiar with this phenomenon. You're familiar with seeing guys like me in front of a urinal for a long time. We don't know that human bladder obstructive syndrome is caused by this phenomenon, but right now this is the only animal model we know of that certainly causes it. Another brief consequence in a different field, some really interesting work on bisphenol A has been published this summer, a combination of mouse work and human work, mouse experiments, human epidemiology, which in essence shows that boys born to mothers with high levels of BPA during pregnancy, by the age of 2, are 3.5 times more likely to show signs of autism and 6 times more likely to be diagnosed by the age of 11. Those are huge epidemiological signals, and they're backed up by data consistent with mice, mechanistic data, which show that the chemicals interference with aromatase activity are involved in this problem. So why is endocrine disruption important? Well, you have to change your mind. It's not about poisoning. It's not about a traditional toxic compound. It's about hijacking. It's about seizing control of development and moving it in a different direction. Like someone goes in and hijacks a plane and takes the plane to Tel Aviv or Saudi Arabia or somewhere instead of to New York. That's hijacking. And chemicals hijack hormone signaling. You also have to know that the hormone system is an amplifier. The hormone signals created by the interaction between a single receptor and the hormone molecule itself, they're multiplied by factors of over 1 million. So one molecule can have a huge effect. And what happens when you start having lots of molecules? The effects are caused by quote unquote tiny exposures. I say quote because in physiological terms, in terms that endocrinologists worry about as hormones are doing their work, those effects are not tiny, and the concentrations, as I'll show you momentarily, are not small, and the numbers of molecules involved are not small. And lastly, which I could go on for about an hour, and Maricel Maffini in the back there is an expert in this, traditional high-dose toxicology, challenged with these low-dose effects, fails utterly. Fails. So the testing systems that we have in place to tell us what's safe and what's not have really not done a very good job with endocrine disruption. EDCs are effective at very low concentrations. Here's just a comparison of where toxic chemicals, the concentrations at which toxic chemicals usually manifest their effects, parts per million to parts per thousand. But both hormones and EDCs are having their EDC effects and their hormonal effects in the parts per billion and parts per trillion level. Very different levels and very different effects. You can have an endocrine disrupting compound at the toxic level, and its consequences are not necessarily endocrine disruption. They are old-fashioned toxicology. So I'll end with this, a question for you, especially for the chemists. Are low doses really low? What is a part per billion? Well, a part per billion is one pancake in a stack of pancakes 4,000 miles high. This is calculations by some friends of mine. Sounds like it's only a tiny amount, but turn that around. If you have a molecule of water, if you have a drop of water, and the concentration of bisphenol A in that drop of water is 1 part per billion. How many molecules of BPA, and remember, one molecule can have huge effects. How many molecules do you think are in that one drop of molecules of BPA? 2.65 trillion molecules. You all remember Avogadro's number, I'm sure. There are 1 billion times more molecules of water, but those 2.65 trillion molecules can cause real harm. So I'll end with this. I think there may be a new day in front of us where we know we have to start reducing the complexity and the number of chemicals we encounter in our lives. We know we can redesign those chemicals. Terry Collins from Carnegie Mellon University is a genius at designing inherently safer molecules. And that's what we need more work at doing, and that's what the chemical strategy for sustainability, the European Green Deal part of, the part of the European Green Deal that deals with this, they're headed in the right direction. We can redesign molecules. And lastly, we've got to fix that regulatory system that just blows it completely with respect to endocrine disruption. So there's some background, and thank you very much.